Our beautiful and complex Australian landscapes are constantly in change. The plants that are here today could well be different to those that were here 500 years ago. Maybe the fire regime was different. Maybe there was less or more rainfall. We can tell by using paleoecology. Paleoecology is the study and understanding of the relationships between organisms and their environment in the past. By reconstructing paleo-environments, we can gain an understanding for modern landscape patterns and processes. And that's important for land managers, people working in national parks, on private properties and on farms. On the 3rd of March 2017, a small class of 14 ANU students and 3 academics set off from Canberra down the Great Dividing Range to Horse Island, a property nestled in the Churros estuary. The location and geology of this island suggested that it could provide reliable sedimentary records, showing the influence of European settlement and millennia of habitation and management from the indigenous people of the Yuin Nation. We were grateful to be given access by Christina Kennedy, who was the 4th generation in her family to own and manage the 80-hectare property. The aim of the visit was to collect sediment cores from 3 low-lying sites, take these back to the ANU labs, and unearth some buried history. After consulting Google Earth, we determined a mangrove locality which had probably remained saturated by the Churros River for the last several thousand years. The class broke up into 2 teams and used a dissection corer to methodically remove sediment 50 centimetres at a time. Yeah, Lachlan's on it. Lucky he's got the arms. It wasn't easy work, but we all chipped in. Yeah, we definitely earned our singers at lunch. Every metre we went down, we added another length to the corer.
And then Stephanie will put that one on. If that's right, yep.
We'd turn the device, secure the core, and then try pull it out of the mud.
And then watch the tree above you again. Just, yeah, keep it over this way. Lovely, nice done, lovely job.
We'd then have a look at the core, describing the colour and texture, and noting down if there was any shells or other big objects. For safe transport, we'd wrap the cores in Glad wrap and then put them in PVC piping.
Many hands make light work.
No, but I just, yeah, I know, it'll look funny in the photo.
Okay.
Yep. And isn't it nice that it's not windy? Because if it's windy, Glad wrap is just a pain. Yeah. The next one sits here, and then we wrap it up and put it in the little green salt.
Then it was back to Canberra to get these cores into the lab.
Isolated the whole fraction, so we make sure all the steps that we're going through the moment, except we didn't do the acetolysis or anything.
Here we took small samples along the entire length of the cores and used acids, a vortex machine and centrifuge to disperse the samples, separating pollen grains and charcoal from the silt.
One of the other things that we do is work really
Our committed little class spent hours, days, counting pollen through the microscopes. We could eventually observe changes in the quantity of charcoal in each layer. Abundant charcoal suggests a large fire took place prior to the period when that specific layer was deposited. In the case of pollen, it is produced by the flowers of plants before getting dispersed and spread throughout the landscape. Some pollen grains will reach other flowers, enabling that plant to reproduce and set seed. But the vast majority of pollen falls to the ground. Now, if that happens to be on a lake or mangrove, for example, there's a chance it could be preserved. The pollen we analyse in our sediment core does not provide a true one-to-one reflection of the plants growing in the environment there. This is because plants produce different quantities of pollen. Some produce a lot, others produce very little, and it's dependent on what vector those plants use to transport their pollen, because many will rely on insects while others will rely on wind. Plants that rely on insects to transport their pollen, insects like flies, wasps, bees, they tend to produce less pollen, and as such we don't get it much in the sediment records. However, plants that rely on wind to transport pollen, plants like pines and grasses, are often overrepresented in the sediment records because their pollen is really far-reaching and they produce so much of it.
No, it's not. It's something odd.
After radiocarbon dating was done in the US, we found our cores to be over 3,000 years old. And thanks to Janelle and Rebecca, we were able to track changes in vegetation and fire frequency through the last 3,000 years. Through our investigation, we argue that Horse Island has undergone notable change, with sea levels once 2 metres higher than today, several considerably large fires occurring in the last 3,000 years, and vegetation constantly in change. This is an island both interesting and now better understood, all thanks to paleo-environmental reconstruction and the class of 2017.